the first in a series of videos going over the solutions to last year's test 3. So I'm going to do parts A and B separate for question 1. So question 1A, you had to balance the following equation in acidic solution. So importantly, make sure that you write down this is acidic conditions change how you're going to do this equation for this reaction. So the first things first, because I'm going to teach a little bit farther than just answering the question, I want to go about figuring out which one is going to be oxidation and which one is reduction. So finding the oxidation states of each of the species in the reaction. So going by our oxidation state rules, we're going to look at this guy here. H is generally +1, unless you have those particular exceptions. O -2, unless it's with fluorine. So S, if we do the math here, has to be +6. Carbon all by itself is 0. Over for CO2, oxygen is -2, following rules. So carbon has to be +4. And again, also for sulfur, oxygen's -2, so sulfur is +4. So you can tell right off the bat, looking at carbon, carbon is being oxidized. This oxidation state is increasing from 0 to +4, and the sulfur is being reduced. So now you know which one of these is which. So if we start out with the reduction reaction, let's do that first. So we have H2SO4 going to SO2. Now, the first things to balance, you're looking at everything besides hydrogen and oxygen, but our sulfurs look fine, so we're good there. Next thing is oxygen. So the oxygens, I have 4 and 2, so I'm going to balance my oxygens with waters. So I need 2 water on this side. Now you're looking at your hydrogens, and this is where it matters if you're in either acidic or basic. So we're in acidic conditions now. I have 2 and 4, so I need 2 more hydrogens on this side. When we're doing acidic, we're balancing with the combo of H3O plus and H2O. It's really hard for you guys to see that. It's really small to get to adding your hydrogens. And then when I do the basic one, question 1B, I'll show you the other way. So we need 2 hydrogens over here. So that means we're going to add 2 hydroniums. And for each one of those I added, I have to balance with the same number of water on the other side. Now we're at balancing charge. For to do that, I need to add 2 electrons on this side. Okay, so there's our reduction reaction. Next one, the oxidation. So we have C going to CO2. Carbon's good. Oxygen needs water. So 2 H2O on this side. Now I have 4 hydrogens. So I'm going to have to balance with 4 hydronium. Remember, we do this with the hydronium because H plus doesn't exist just by itself. It's attached to water. So every H plus I add, I have to add an equal amount of water to balance that out, each hydronium. And final thing is our electrons. So we have 4 electrons over here to balance the whole thing. Remember, when you want to add these 2 together, you have to cancel out your electrons. So let's take a reduction reaction times 2, then we can add them all together. So I'm just going to bring it down here, times 2. So we have 4 electrons, 4 hydronium, 2 sulfuric acids, 2 SO2. I have 4 waters, now I'm up to 8 waters. So I'm adding these 2 together. Go through, I can cancel out my electrons. And looking at the amount of water I have 6 waters and 8 waters. Let's get rid of those 2. Bring this one down to 2. Hydroniums, 4 and 4. Those cancel out. So overall now I'm going to have 2 H2SO4, it's carbon, going to CO2 plus 2, SO2 plus 2 water. And there's your final answer.